Problem number 11. You see it, we have a right triangle here. It says find the value of each of the 6 trigonometric functions of the angle theta in the figure. So theta is over here. I don't know why they do this, but they label this A and B and then give you the numbers here. You would think they could just write the numbers here. So a right triangle, this is where we use the SOHCAHTOA to find sine, cosine, and tangent. And then once we know sine, cosine, and tangent, then we can easily get the remaining 3 trig functions. First thing we have to do is Pythagorean formula. Then we did over here, there's not much room here. To find the length of this hypotenuse, we take the square root of one of the legs and we square it and add it to the other leg squared. Now I know 12 squared is 144. I don't know for sure off the top of my head what 16 squared is. It's actually 256. Now if looking at this, this is going to be square root of 400, which I know is 20. So it turns out hypotenuse is 20, so that's nice. No square roots or anything here. So now I simply go through these definitions to find the sine, cosine, and tangent. The only thing I have to do is maybe be careful to reduce my fractions. So the sine, I'll just do it here. Opposite, so here's my angle. Opposite side is here. So opposite over hypotenuse. I can reduce this down to 3/5. Cosine, so ca adjacent 16 over hypotenuse. If I divide top bottom by 4, looks like 4/5. Tangent, TOA, opposite over adjacent, so opposite over adjacent. Divide top bottom by 4, you get 3/4. So that's using the trig functions for a right triangle to find, well, we're finding the trig functions of a right triangle using these definitions. Now, the 3 remaining trig functions, you have to remember cosecant, so it gets paired up with the sine, and it's the inverse. So what you can do if you have a sine that's like a fraction, if you flip the fraction, that becomes the cosecant. Secant is paired with cosine, so if I take the cosine and flip the cosine, I have the secant, and then cotangent and tangent are inverses. The tangent's 3/4. The cotangent is 4/3. So there you go. Not too bad. So here's another similar, but they don't give you a right triangle. Instead, now just so you know, this wording use definition or identities. Okay, I'm going to use what we call the definition. Bottom line is they give us the cosine of theta is 1/6. They want to find the 5 remaining trig functions. Now it's important, they tell us it's an acute angle. That means our angle's in quadrant 1. That becomes important because later on We will probably have problems where the angle is not in quadrant 1. We have to know the quadrant of the angle because that's going to determine whether our answers are positive or negative. Since we're in quadrant 1, all the answers are positive in quadrant 1. So I don't really have to worry about that for this problem, but later on I do have to worry about the quadrant. What I like to do, the way I do these, I use the definition of cosine. Cosine is adjacent over hypotenuse. So I come and basically say, I'm going to take and create a right triangle based upon the adjacent side being length 1 and the hypotenuse side being length 6. So I just draw a standard looking right triangle. Here's theta. Here's my right triangle. So it's telling me that the adjacent side is a length of 1. Hypotenuse is a length of 6. Now I'm going to use Pythagorean formula to find the length of this third side, and once I have the length of this third side, I now have 3 sides of a right triangle, and I can use my trig definitions to find the other trig functions. So Pythagorean formula to find this side, it's you take the square root and you take the hypotenuse and you square it. 6 squared is 36. And you subtract the other side squared. Well, 1 squared is 1. So square root of 35. So this side here, so it's going to be a little messy. Now, I'll say it again, they want exact values, which means I'm not going to grab my calculator and punch in the square root of 35. I just leave the square root of 35 in all the answers. So now I've got a right triangle. I know the 3 sides. I can now go get all the trig functions of this angle theta. The first thing they ask for is sine. Sine, so katoa, opposite, square root of 35 over hypotenuse, square root of 35 over 6. Tangent, so katoa, opposite over adjacent. Opposite is square root of 35, adjacent's 1. Well, I'm not going to write a fraction with a 1 in it. Instead, I just put square root of 35. So now I know the 3 main trig functions. They gave me the cosine, I have the sine, I have the tangent. To find the remaining trig functions, I'm just going to flip all these fractions. Cotangent, I just have to flip the tangent. If I think of this as being over 1, so now since I want to flip the fraction, I do go ahead and think of a 1 being there. So if I flip this fraction, you get 1 over square root of 35. The cosecant, I'm going to flip. Cosecant gets paired with the sine, so you flip this. Now, a lot of you learned in algebra that you never leave, they used to never like for you to leave a square root or a radical in the denominator of a fraction. Well, you get the trig, they don't care so much about that anymore. So these answers will be fine. And then finally the secant. The secant gets paired with the cosine. If we flip 1, 6, we get 6 over 1, or we just write 6. All right, so that's how you do those 2 problems using our trig definitions of a right triangle. Let's go ahead and do a few more problems for this video. The Number 13 says, find the exact value of the expression. They even tell you, don't use a calculator. That's what I keep telling you. Of course, this is only going to work because these are actually special angles. So now, if you haven't memorized them yet, this is where the unit circle becomes invaluable. So this is pretty straightforward. 4 times the cosine of 45 degrees. Go to your unit circle, find the 45-degree angle. The cosine is going to be the x value of this point. This point here is square root of 2 over 2, the x and the y. The x is the cosine of 45 degrees. So the cosine is square root of 2 over 2. So I put in the square root of 2 over 2. So 4 cosine of 45 degrees minus 5 times the sine of 45 degrees. Go back to 45 degrees. The sine is like the y value here. Turns out it's also square root of 2 over 2. Now I need to simplify this if possible. 4 times square root of 2 over 2. Well, 4 over 2 is 2. So this becomes 2, well, let me write it here. 2 square root of 2 minus 5 square root of 2 over 2. Now sometimes what they like you to do in trig, and if I look at the answer here, they in fact want you to do it here. They want us to combine this into one fraction. So if I'm going to subtract this, I have to have a common denominator. Well, here I have denominator 2. Here, if you want to, you can think of it as denominator 1. I can't subtract these right away. I need to get a common denominator. What I'm going to do is multiply this by 2 over 2. So this becomes 4 square root of 2 over 2 minus 5 square root of 2 over 2. So now that I have a common denominator, I can actually combine these into one fraction. There's my common denominator. 4 square root of 2 minus 5 square root of 2. It's almost like 4 minus 5. So really it's negative 1, or what we just do is write negative square root of 2 over 2. And that's a correct answer. Actually, the trig part of this is pretty easy. Maybe the more difficult part was trying to simplify the answer. The next one's very similar. Here's this expression. Sine squared of 45 degrees plus cosine squared of 60 degrees. These are special angles. Sine squared of 45 degrees means you go get the sine of 45 degrees and you square that number. The sine of 45 degrees, here's 45, the sine squared of 2 over 2. So square root of 2 over 2, since it's squared, plus cosine squared of 60 degrees. 60 degrees is here. Cosine's the x value. Sorry, cosine's the x value. So cosine of 60 degrees is 1/2. Except I'm going to square it. If you remember from algebra, when you square fractions, you square both the top and the bottom. If you square the square root of 2, you get 2. If you square 2, you get 4. So this becomes 2/4. Here, 1 squared is 1, 2 squared is 4. Looks like I can add those together and get an answer of 3/4, which is correct. Let's see if there's any more of these problems where we stop. And it looks like actually there is not. But I'm going to finish these. There's 4 more problems, but these will go pretty fast. Let's just do these. So here, number 15, now they tell you, use your calculator to find the approximate value of the expression. Run the answer to 2 decimal places. In case you can't see this, they're asking for the sine of 69 degrees. It's not a special angle. That's why they're not asking for exact values. So this one's pretty simple. But here's the key. All right, using your calculator in trig class. I want to use my sine key. Here's my sine key right here. I want to take the sine of 69 degrees. The calculator has to know whether you're going to enter the angle in a degree or radians. In other words, for my calculator, if you look up in the top, maybe you can see it. It's a little, I don't know if I can focus. You see above the 0, it says DEG. That means my calculator currently, if I'm going to use the trig functions, it wants me to put in the angle in degrees. And here I have a button, if you can see if it switches, and it just switched. You can't really read it very well, but now it reads RAD, so now it's in radians. So for this problem, let me get this focused again. For this problem, I'm going to enter my angle in degrees, so I make sure my calculator is expecting the angle in degrees. And it's a pretty simple problem. I put in 69, and I go hit my sine key. And this says round to 2 decimal places, 0.933. Well, .93. Maybe the easiest problem you'll have this whole class. Next one's similar, except now they give me an angle in radians. Just to make sure you can see it, they're saying what is the sine of pi over 8? Round to 2 decimal places. So once again, now my calculator, currently it's in the degree mode. I have to make sure it's in radians. So I hit a little button on my calculator. Now it's expecting the angle in radians. So now I go in and I type pi divided by 8 equals. So pi divided by 8 is like 0.3926. But I'm going to take the sine of it, hit my sine key. 0.382, so 0.38. And that is correct. I think there may be one more. All right, this one's a little tricky. They're asking for the cosecant of 10 pi over 13. Most calculators like mine, I don't have a cosecant key. So I can't just punch this into my calculator. However, cosecant is the inverse of sine. Cosecant and sine are paired together. What that means is, let me write it like this. If I have the cosecant of an angle, that's the same thing as 1 over the sine of the angle. So cosecant of theta equals 1 over sine of theta. Here my angle is this. This is the same thing as the sine of 10 pi over 13. Now what happens is I can go to my calculator and I can determine the sine of 10 pi over 13. So I'm going to have my calculator figure this out and then stick it in the bottom of this fraction, and then I should be able to have my answer. Now the nice thing is my calculator has this little, you see this little 1x here? That means I can do a calculation and hit that key and it moves it to the bottom. So I'm going to use that key in a minute. First thing I'll do is I'll figure out this trig function. So I got to make sure I'm in the radian mode, because this angle's in radians. I'm in the radian mode. So 10 times pi. You have to use the pi key for these kinds of problems. Don't type in 3.14. You need to actually hit the pi key. So 10 times pi divided by 13. So 10 pi over 13 is 2.4166. I'm now going to hit the sign. And for me, I can hit this key, and it's going to take, so this whole thing, 0.663 is this right here. But if I hit 1 over x, just to make it clear. So really, if your calculator doesn't do this, you should probably write this out. And then do this calculation. But I can do it automatically by hitting 1 over x. And I get 1.508. 0 is my second place. It gets bumped up to 1.51. And that is the answer. All right, one more last problem. Back to sort of right triangle trigonometry. It's a little bit of a story problem. Let's see if you can see. They're saying find the distance from A to C across the gorge. So this is some kind of a gorge, and the distance across it is from A to C. So this is what we want to figure out. And what we know is the distance from B to C is 120. And if you can see, it's like a 35-degree angle from B to A. So if they sort of drawn it for you here, it's basically we have like a right triangle. And we know this distance, you can think of this as the right angle. We know the angle here. We can actually use a trig function to determine this. Now if we think of this as a right triangle, and this is my angle, if we think of hypotenuse, opposite, and adjacent, this 120, which side is this if this is my angle? Well, this is my adjacent. And what I want to know is, which side is this? Well, this is the opposite. Now, which trig function relates the opposite side and the adjacent side of a right triangle? So-called TOA, right? TOA. The tangent of an angle is the opposite over the adjacent. So what I can do here is, the angle is 35 degrees. I don't know the opposite, but I know the adjacent's 120. And now, by doing a little bit of algebra, I can determine the value of the opposite. If I want to get this opposite, this O by itself, I'll multiply both sides by 120. So really what I'm saying is this opposite side is going to be 120 times the tangent (35 degrees). So you get your calculator, and it's saying, you can't see it here, but it says round it to 2 decimal places. You got to make sure your calculator's in the degree mode. Right now my calculator's in the radian mode because I was just doing a problem with radians. So I'm going to make sure my calculator is in the degree mode. You can see here it says radians. Now it's in degrees. So I'm going to say 35. I'm going to hit my tangent key. Right here's my tangent key. Times 120 equals, and that should be the answer. 84.02. The next digit's a 4, so it says 84.02. And that is the correct answer. So a little story problem that really is a right triangle. So the trig function gives us a way to solve this story problem. All right, we will continue with the next video.